There's three ways we tackle simplifying expressions. One is combining like terms. The other one is distributive property. Another one is order of operations. And there are other ones out there, but these are the three that we're going to tackle as we go forward, all right? Now, I want you to consider for a second as we go into the combining of like terms. I want to do something or talk about something that's relatable to you, okay? Now, while I was doing this, I was trying to figure out what is something that everybody has in their house or everyone can say I own something of. When I was younger and we started talking about combining like terms in school, they used to talk about marbles. And I wondered, do kids even use marbles these days? do people play with marbles anymore? And I don't really know. So one of the things or something that I thought everyone probably can relate to is clothes. All right, so everyone should have some clothes somewhere, hopefully. And if you don't, just use something you do have. But clothes. So imagine someone comes in with a hamper full of clothes and they say to you, okay, I want you to, sort these clothes out. I want you to put the pants in one section and the hats in one section and the shirts in one section. How do you do that? Well, let's take a look. I sorted them for us. All right, so we have all these hats, we have the shirts, and we have the pants. And for the most part, depending on how organized you like to be, you'll probably go ahead and put all the shirts in one drawer and the pants in one drawer. And then some of us like everything just in the same drawer and we'll just dig through it to find what we want. But in math, we love to sort as well. And we use expressions and we use terms as tools for sorting. All right. So in math, like I said, we love to sort also. We don't like things all over the place. We like things in order. And so what does that mean? Well, usually what we'll do is, in order to sort in math, we'll take something like a hat. Let's say the group of hats that we have here, right? And we'll say, okay, I'm going to use, so we have all these hats here, and we say, okay, I'm going to use a variable to represent the hats. So X is the variable I'm going to use to represent all the hats that I have in my disposal, in my ownership or my hamper. And then they'll say, okay, perfect. So all of the hats, I'm going to use the letter X or the variable X to represent. And then they'll do the same thing for everything else, but they'll give them different variables or different letters. So for all of the shirts I have, I'm going to use the variable Y. And then for all of the pants, I'm going to use the variable Z, all right? And honestly, X, Y, Z, you can use any letter, it does not matter. But X is very popular and Y very popular. It's just a habit. So either way, you can use any letter you want. But let's keep on going and see how we sort in math, okay? Okay, so now if you take a look at this, we already established that, okay, we're going to use X for the hats. But now it's not enough just to use X to represent the hats. We also want to know how many hats we're dealing with, right? We're not just dealing with any number of hats. We're dealing with a specific number of hats. And in this case, we're dealing with 5 hats. I hope I count. Yep, 5 hats. And so what we'll say is, okay, if X represents hats, then I have 5 X's or 5 hats. All right, so 5X represents the 5 hats that we have. And similarly, the same thing applies for the shirts. I have shirts and they're represented by the letter Y or the variable Y. And so I count the number of shirts I have and I happen to have 3 shirts. So that also means that I can represent the number of shirts I have using the expression 3Y. All right. I want you to consider or think about that for a second. Make sure I'm not losing you along the way. And then let's take a look at the pants. Same thing for the pants. We said, okay, I'm going to use a Z to represent all the pants. But I want to make sure I'm specific about the number of pants that I have. So I have 4. Well, 1, 2, 3, 4, 5. I have 5 pants. So I missed one. So I have 5 pants. So I need to have 5Z, okay? 5Z, 5 pants. All right, so that's how we sort in math. We like to combine the things that are alike. We like to bring them all together and make sure we're counting them all up. Why is that important? Well, because when you do your exam, they're going to ask you to do something called simplifying. And we already established that there's different ways to simplify. And one of those ways is by combining the things that are alike. So let's take a look at some examples of simplifying expressions, all right? And these questions are very similar to the ones that are on your examinations. So I want you to take a look with me, all right? So this one I pulled exactly from the exam as it is. So we have 3x plus 8x minus 12x. Okay, awesome, no problem. So let's go ahead and see, how do we simplify? Well, we can simplify a couple of ways. And specifically, we're talking about combining like terms. Now, how do I know that they're like terms? How do I know that they're alike, that they can actually be combined? Well, remember in our earlier slide, I'm going to put it back up for you. We said that, let's go back. Yeah. So the hats are represented by the X and the shirts are represented by the Y. That's how I know that they're alike, if they have the same variable. And we'll learn a little bit more about those variables in a second. But with that being said, let's see if these are like terms. Well, the variable here in this term, the 3x, the variable is X. Okay. Are there any more X's? Well, the answer is yeah, I have an X here and I have an X here. All right, now pay attention to this for a second. So if they all have the same variable, are they all alike? Well, in this case, they all have the same variable, but also notice that they also, all of them have the same, well, in this case, they don't have any exponents shown. I put those little circles there. They're not supposed to be zeros, but they're just circles there to show that the exponent on top of them, there's no exponent on any of them. So that means they're all the same. So, and that's going to come into play a little bit later. But let's go ahead and do the math. Now, if you recall, there is an order of operations that we like to work with. So if I see multiple operations in an expression or an equation or whatever it might be, there's a preferred order. And that's where we talk about PEMDAS. Some of you may have heard of another one called BODMAS, but we're not going to go into too much about order of operations because there's a video on my channel about order of operations that you can check out if you're not sure. But in this case, the last part of PEMDAS says A and S, which is addition and subtraction. So we prefer addition to subtraction. Some of you say from left to right. Either way, it is what it is. So let's go ahead and add first and then go ahead and subtract. Now, like I said, there's more in-depth conversation and explanation about PEMDAS in that video, about what do I mean by, okay, addition and subtraction versus left to right, right? We're going to clarify that in that video. So let's keep going. So we're going to add first. And so we have the 3x plus 8x. Now, I want you to think of this as if I'm saying I have 3 pants or 3 hats. And I'm adding 8 more hats, all right? Because the X represents the number of hats that I have, or whatever item you want, marbles, candies, ice cream cones, whatever it is. The point is the X is just representing an item. So I just have 3 of those items. So 3x means I have 3 hats and I'm adding 8 hats to it. So I have 11 hats in total, so 11x. And I'm going to make sure I bring down that 12x because I didn't do anything with it as yet. And now I'm subtracting 12 hats from the 11 hats. That's kind of interesting. How can I subtract more hats than I actually have? Well, let's consider that for a second. If you're going to a store and you want to buy something and they say it costs you $11 or $12 or whatever it is, but you only have 11, what you'll probably do is you'll say, okay, I have 11. You probably will go home because you don't have the money for it. But if you have a friend that you know have money, you'll probably say, okay, I have $11 and I'll borrow $1 from my friend. And so when we're talking about subtracting numbers that are larger, then I want you to think of it as, okay, whatever I don't have, I have to borrow the rest. Okay. So with that being said, I have 11 and I'm subtracting 12. So that means I'm going to end up with -1 hat. So I'm going to end up owing someone a hat. Another way you can do this is by saying -x, okay? Because the 1, you don't have to put the 1 if it's 1 hat. You can just say, okay, I just have a hat. All right. So let's keep going and see some more examples of this. All right. So we have simplifying expressions and we have another expression here. But remember, we're combining like terms. So let's look at the like terms and we determine the terms based on the variable. And there's another piece that's going to come in the next question that has to do with the exponent. But let's focus on the variable for now. So we have an x here and we have an x here. All right, perfect. So now we can consider those two terms, whether or not they can be combined or how, based on the variable. So now if I take a look at them, notice that both of them, neither of them have any type of exponent there. So the assumption is that the exponent is a 1. So they have the same variable. So I can combine them. So how do I do that? Well, I have 4 hats. And remember earlier I said that the sign matters. The sign that's in front of the term matters. So I'm subtracting 2 hats. All right. And then let's take a look at another group. I have y's in here. So I have a y here and a y here. And so they are like terms based on their variable that's there. All right. And so I can say, okay, I have plus 7 shirts and I'm adding another 3 shirts. All right. So what do I have in total? If I have 4 hats and I'm subtracting 2 of them, then I'll have 2 hats left. And then I'm adding to that, I have 7 shirts and I'm adding 3 more shirts. So I have 10 shirts in total. All right. So this is going to be how I simplify the expression. Now, some of the confusion that may come is that you might wonder, well, or better yet, I've seen some students where they'll put y equals something, or they feel like they have to have an equal sign in their answer. And so the confusion can be, okay, how do I know when I'm solving for when I need one number in my answer versus a letter? How do I know? Well, this is where the difference between an expression and an equation comes in. And this is something I didn't say earlier, but whenever you have an equal sign and maybe another expression or a number, let's say 2x over here, an equal sign tells the difference between an expression and an equation. And an equation is 2 equivalent expressions, okay? In other words, you'll have an expression on one side of your equal sign and an expression on the other side of your equal sign. And we'll talk about solving equations in another session. But when you're dealing with simplifying expressions, all you're doing is combining like terms, getting rid of parentheses where you can. If you see that you can add or subtract or multiply and divide, you're trying to apply as many of the operations as you possibly can based on the expression given. And so if you take a look at my answer for a second, I have 2x plus 10y. If you're wondering, am I done? Is this it? The answer is yes. And how do I know? The way you know that you're done when it comes to simplifying expressions is asking yourself, can I combine anything else? Are there any more like terms here? And if you look at this, what I have 2x. In other words, I have 2 hats and I have 10 shirts. Hats and shirts are not the same, my friend. So no, I can't combine them. And so I'm done. That's how I know that I'm done. And if you're not sure, go and ask your teacher. Say, okay, I did all the steps. I just want to know, okay, am I done? Is this what you're expecting of me? I'm hoping your teacher's not going to be like, get out of my face. I'm tired. Like, no, I hope not. If that's your experience, I'm so sorry. But for the most part, if you ask your teacher, more than likely they'll say yes or no. Okay. All right. And the last thing is this. I wanted to show you this because you might see this in an exam and wonder the same thing. So earlier we said, okay, based on the variable, that's an indicator of whether or not they're like terms. So let's look at all the variables and see, are there any variances? Is there anything different that I need to consider as well? So I have an x here, I have an x here, and I have an x here. All right. Now, are they all like terms? Some of you might say, yeah, they're like terms. But I want you to take a look at what I also showed you earlier. I want you to look and see, are there any exponents involved? All right. Because the exponent also plays a part. The exponent on the variable plays a part in whether or not they are like terms. All right. So here we go. If you notice the first term, which is the 6x to the power of 2, that's the only term that has an x with a power of 2 on it. So that term is not the same as the x's that do not have a power of 2 on it. All right, so what does that mean? And you can replay that again if I confused you a little bit. But what that means is that the only two like terms among the x's would be the 4x and the 5x, because they both are just, they only have an x. But the first term, which is 6x squared, that's going to be different. All right. So with that being said, let's go ahead and combine our like terms. So we have the 6x squared. Because there are no like terms to that one, I am just going to write it back. I can't do anything with it. All right. And if you cannot do something with a term, you just rewrite it and you're good. All right. So now 4x, so like 4 hats plus 5 hats is like having 9 hats. So 9 hats. Perfect. All right. Now let's take a look at the 7 and the minus 6 for a moment. So we have a plus 7 and we have a minus 6. Now the question might be, are they like terms? Well, these two numbers would be considered constants. All right. Constants, remember, they are numbers that do not have a variable attached to them, do not have a letter. So 7 minus 6 is literally just 7 subtract or take away or minus 6, which is just going to give you 1, specifically a positive 1. And so this is our final answer, right? There's no necessarily any equal. I have a lot of, I have more terms, but it's simpler than where I started off. And if you look at it, I have no more like terms, so I can't combine anything else. And so I'm done. I'm all done.